That's what you've noticed right here, Kurt, is that yes, you do win. But when you win big, only 7% of the time, the 93% of the time that you don't win kind of undermines that. Exactly, my friend. Totally exactly. So we now can get, Matty, go ahead.
0.7% of the time.
No, it's actually 7%. That's if you add these two together, it's 7.3%. Right. This down here is 0.6%. But you're also winning in this one right here. Is that fair?
I see what you're saying now.
You see what I'm getting at?
Pointing to the bottom.
Oh, no. The bottom one plus the one right above it. Because I think what Kurt was looking at is those bottom two are the ones where you realize profit. The top two, you either break even or lose. Now, 93% of the time, you break even or lose. But people ignore that. They focus on the big payout. That's the problem. That is the challenge. Fair enough? Okay, let's go over to the sideboard. And let's figure out on average, oops, as I unplug my camera. Let's figure out on average how much we win per game. Because we now have everything we need, to calculate our GPA. We've got our classes, don't we? We've got statistics, we've got econ, we've got anthropology, we've got science, and we have the credits. That's what we needed. We needed the credits. Say that again. Psychology, sure, it's all good. But we have the credit loads now. Now I can ask you, on average, how do we do? What's our GPA for Chuckaluck? It's still a GPA. It's still a GPA. So what's our GPA or average winnings for Chuckaluck? Now, what you have to remember is how we did the actual weighted average in class last time. So what I'm going to do is, in purple, maybe, or some other color, here, green, I want to revisit over here on the sideboard how we calculated our GPA. Okay? Because the same exact logic is going to happen here. So for the GPA, literal GPA example, what we did, and again, you can look at your notes and see how this all shakes out. We actually took your grade. You're not going to see that video. Hang on, let me get a darker color. I just put in for a better video camera. Like the GoPro. We took our grade in class 1 times the credits in class 1. We added to that the grade in class 2 times the credits in class 2. And we keep doing that. We keep doing that all the way along until we've gotten all the credits and all the grades taken care of. We're going to put dot, 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 yeah, dot, dot, dot. And if it's okay, I'm going to put grade in last class times the credits in the last class. And that was a big, long computation on Thursday. Big, long computation. And that was the summation of all the data. And what do we divide by? Do you remember? Yes. You divide by the sum of those credits. That's what makes it a weighted average, is the credits. The credits here as well as the credits up here. And that's why I love what Cheryl said earlier. When she said, as soon as we started that Excel simulation to get those numbers up there, you said, watch this, they're going to even out. And I said, haha, let's watch to see if they do even out. Because if those things did even out, this would be an easy thing to calculate. If that bar graph at the end of the day was perfectly horizontal, 25%, 25%, 25%, 25%, we would have been done an hour and a half ago. We would have simply added up -1, 0, 1, and 9, divided by 4, and said, go home, we're going to make 225 per game. But you know that doesn't happen because of what Kurt said. Kurt said you don't win very often. Yes, you don't. With the outlier accounted for, like you said earlier, Cheryl, we hardly win at all. When we do, we win big, but let's see how that winning big offsets what actually happens in the game. Cool? All right, here we go. Let's apply this modular kind of approach to our Chuckaluck problem. Let me come over here. All right, here we go. We take the grade in Class 1. For those of you not playing the home game, grade in Class 1. What's the grade? What is beeping? Is that me? Is that my... Maybe it's the camera. It's charging and it's recording. What's our grade? I'm sorry, George Carlin, I'm sorry. You're looking down at me in heaven, watching me put quote marks in the air. I know you don't like this. What's our grade in Class 1? What's our grade in Class 1? -1. We lose $1. That's our grade in Class 1 is we lose, essentially. We roll no 5s. So the grade in Class 1 is that -$1. Say that again? It's the first payout, and I put that in quotes because you're actually losing. You're not bringing any money in at all. You're actually giving money to the dealer. What's the credit or weight for that class? 0%. Yes, 57.8%. That's the first part of your GPA. But that's not all that can happen. I mean, it happens a lot. It happens 58% of the time. But there's other stuff that happens too. What's your grade in Class 2? Break even. You got to break even as well, don't you? You break even with no money. And what's the weight for that part of that class? 34.9. Yes! 34.9%. That happens roughly 1 in 3 times. Roughly 1 in 3 games. You're going to roll. And then, again, this is what keeps people playing the game. Roughly 1 in 3 times, you see one of the numbers you bet on. It's like, oh my God, I'm on the comeback trail. No, you're not. You're seeing probabilities kick in. That's all you're seeing. Okay? How many more classes do we have? 2 more classes. Next class, this is the first of the we begin to win something class. The payout is $1. And it happens how often? Yeah. 0.067, 6.7% of the time. And last but not least, the big break even, or the big payout is $9, but it only happens. Extra 6 in there, extra 0 in there. There you go. Now, here's where probabilities are more advantageous to us than the GPA credit calculations. We technically have to divide by the sum of the credits. And what are the credits in our example? The credits are actually the probabilities, right, Tiffany? You said it over there. Cheryl, go ahead.
That says 9. Shouldn't that be 2? Wouldn't you have 9?
Well, it's because you get 10-to-1 payouts when you.
Forget that.
Oh, it's much better than 2. It's much better than 3-to-1. It's 10-to-1, my friend. Is that fair?
Yeah.
Kate?
If you're not that credit, you just divide it by 1, so you don't need to do that.
Why do you just divide by 1?
Because it all adds up to 100%.
Check this out. Don't write this in your books, but I'm going to write something and then erase it to show you why it's unnecessary. Technically speaking, we have to divide this by the sum of all the credits. I mean, that's the whole idea of an average. You can't divide it by 4 because there are more than 4 credits in your GPA. What are the credits equivalent to over there in our little distribution of numbers? The probabilities, well, the probabilities, correct? So if we summed up those probabilities, if we actually summed up that column called probabilities, what would it sum up to? 1 or 100%. So you'd actually be dividing by 1, which doesn't change anything. Does that make sense? Go ahead, Chris.
Yeah, well, I have that.
But you don't have to. That's why I said don't write it down. I just want you to realize that because we don't write it, that doesn't mean it's not happening. It's that it's being divided by the number 1, which doesn't change its value, so you don't have to do anything. All you've got to do when you're doing these expectations or these averages based on a distribution of probabilities like that is multiply payout, likelihood, payout, likelihood, payout, likelihood, payout, and add them all together. The division by 1 is already taken care of. It's not like a GPA. A GPA, you have fixed credits that you have to sum up. These always sum to the same thing. They always sum to the same thing. So all we've got to do is add it all up. Let's do it. Let's do it. We got, actually, you probably do it, but you probably do it over here without too much trouble. This is negative 57.8 cents. Whoa. Hello, Chip. That's negative 57.8 cents, which means this amount of money is contributed the 57.8% of the time that we lose, essentially. So this is on a bet of $1, remember. This is on a bet of $1. On a bet of $1, this much is lost via not rolling the number you bet on. Plus, What's this right here?
0.
That's 0. Well, that makes sense. The third of the time that you get one of your numbers back, you don't win any money. Over here, what's this guy? Yep, 0.067. That's important, isn't it? Because if it was 0.67, that's actually winning 67 cents, but this is actually winning 6.7 cents. So that contributes to the average in a positive way, because over time, that's going to contribute 6.7 cents over the dollar that you bet. And last but not least, over here, what's that, 0.054? So that's 5.4 cents. So that's contributing 5.4 cents to the overall average. Summing all this up, we end up with our average. So we end up with, let's see if we can do this. That's going to be 0.121, I think. Check my math on this one, friends. Plus 0.121, which adds up to negative, I get, am I doing this right? 754. I get negative 457? So on average, we're losing about 50 cents per game, which agrees pretty close to what we actually got in class together. About negative 0.6. This is negative 0.5-ish. So in other words, rather than playing the game, just walk up, hand the dealer 45.7 cents, and walk away. Because on average, that's going to happen anyway. That's the idea. Every time you play this game at Vegas, Vegas earns 45.7 cents from you.
That's why if you're ahead, you better lead fast.
It's interesting that Cheryl brings this up. Have you ever seen the movie Casino?
Yeah.
Remember the scene with the Japanese business guys?
It's been a while.
It's been a while. It's been a while for me too, but I remember this vividly because it illustrates that perfectly. Bunch of Japanese businessmen go into De Niro's casino in the movie. And they hit it big at, I think it's blackjack, I'm pretty sure. It's some chance-based game. Not a skill-based game, but mostly a chance-based game. And they clean up. They clean up and they try to leave. And what does De Niro do? He calls the airport and says, we have to shut down their flight. And then they go to the airport. The flight's shut down. They come back pissed. And he's like, oh, I'm terribly sorry. I'm terribly, terribly sorry. Your flight's been canceled. Tell you what, come back into the casino. Have the penthouse, best room in the house. Here's a few thousand more in chips. Go, have a good time. Keep playing. Keep playing. Because what is he allowing to happen? That. He's allowing that to happen. Remember how we were hitting more fives than we should have in the beginning of this? We were like the Japanese business from Casino earlier today. We were hitting 3 5s too much. Had we stopped right then, we would have actually been making more money or losing less money, I guess is probably more accurate. But when you keep playing, as Cheryl said, when you let the probabilities actually kick in over time, you can't escape this. You can't escape this. The only way you can escape this is if you cook the dice somehow. You got to realize too, this is a pure game of chance. There is no skill involved in this game at all. It involves things like roulette, one-armed bandits, things like that. This isn't poker. Poker's a whole different animal, right? Because poker, there's a skill involved in that. So I never analyze things like poker. Even blackjack has a bit of skill. You have to know when to stop drawing cards. Games of chance, roulette, craps, for example. Craps is a fantastic example. I might actually design a craps thing for us to play in class on Thursday. That might be kind of a fun way to tie it in. Do you want the actual answer?
I just don't. I just would never play any of these damn games. It's just ridiculous. That they're even allowed to create this.
Well, Maddie, they don't twist your arm to make you go to the casino.
No, I know.
I mean, you go in voluntarily.
It just shows how.
Careful, brother. I'm not trying, and this is a good point. I'm not trying to paint gambling as negative, other than on average. What I'm trying to show you is, on average, you're going to lose money. If you go into it with that idea in mind, you might enjoy yourself.
Right, if you're willing to pay 50 cents per game to just play a game.
To just be in the casino, have a good time, get free drinks handed to you, maybe.
If you know you're going to lose your money.
If you know you're going to lose your money and don't view it as an... I mean, this is the one thing I love state lottery. They always put on the billboards, not to be used for investment purposes. Because no investment in their right mind would have a negative expectation.
Right.
I mean, sometimes you lose money in investments anyway, but that's because the market goes south. But generally, you want investments to earn you money, not lose you money. So if you can view it as pure entertainment, I mean, think of it this way. How many of you go to the movies to watch movies every once in a while? Well, hell, I mean, you can wait for it to come around on Netflix and get it for pennies, but you pay $15 plus if you buy popcorn, you end up paying $20, $25 for the entertainment of sitting in the theater for, an hour or two. and having the atmosphere, the enjoyment of it. I mean, is that worth your time? It might be. All I'm saying is, on average, you're going to walk out with less than you walked in with, roughly half of what you walked in with. If you can live with that, that's the existence of the game, right? You might walk out with more. I used to have a friend, Rocky. He used to walk in every casino. We used to play shows down in the Southwest, back before casinos kind of spread all over the country. And there were quarter slots everywhere you went, bathrooms, churches, wherever. And he would walk in with four quarters in his right pocket. And he'd play exactly 4 games, and whatever he won, he put in his left pocket, and then he'd walk out. And sometimes he walked out with more than he walked in with. Sometimes he blew all 4 and walked, but that was his control. That was his control. And I've counseled people to do the exact same thing. If you want to treat it as fun, don't view it as something you're going to feed. Don't say, I'm going to play till I win, because you're not going to win. This guarantees you're not going to win. This is a guaranteed way of turning $1 into 50 cents. Essentially is what that is. That's a guaranteed way of taking your dollar, cutting it in half, and walking off with half of it. Please, Matt.
So I met a friend the other night, and there's this kid playing video poker or whatever.
Okay.
Or not even video poker, just a video.
Like a one-armed bandit video. Yeah.
He was up to like 265. He had won 200, and I said, why are you going to keep going? Why don't you just walk away, and 5 seconds later,
It was gone.
0.
Because you understood something he didn't.
But I still don't get this. Like, this still
Well, then you got
makes no
personality.
sense.
That's just a-
When you say, give me more on that statement, Matt.
With numbers, the numbers don't, the number thing makes no sense, but.
What number thing? Which, the probabilities?
Yeah. Like,
What that means, Matt, what these probabilities mean is roughly 58% of the time, whatever number you bet on, you won't get any of. Now, all that means is, when we press F9 and roll the dice 3 times, 58% of the time, we did not get what we were betting for. You're looking at one right there. We got a 3, a 2, and a 4. We bet on 5. We got nothing that we bet for. What this means is, roughly 35% of the time, one of the 3 dice will have a 5 on it. What this means here is, roughly 7% of the time, 6.7%, roughly 7% of the time, you'll see 2 5s on the dice. And what this says is, you hardly ever see all 3 dice having the number you bet on. That's all that, it's a percentage of occurrence. It's a probability. It's a percentage of occurrence over time on average in the long run. So, 58% of the time, you're going to lose $1. 34% of the time, 35% of the time, you're going to break even. 6.7% of the time, you're going to win $1 back, and basically never, you're going to win $9 back. That's all that means, friend. What your friend had happen to him was he was hitting this more than he should have been hitting early on. So his average was abnormally high. It's almost the same thing if that graph that you see up there on the screen was lopsided. That's what was happening to him. He was hitting too much on the right side. And what happened over time? It corrected. It corrected back to what it should have been. You had a right intuition. Your intuition was correct. Kurt, just like your intuition was correct earlier. You said 66%. Damn close. Roughly 2 and 3. Roughly 6 and 10. That's roughly the same number. You're only off by 5 or 6%. You have a great intuition. But all this is it's nailing it down a little more quantitatively, Maddie. So your intuition's spot on. Is that fair? Yeah. Awesome comment. Thank you. Scott, go.
You know that like people are trying to buy into this delusion that they're going to take the house. Like if you go into a lot of casinos and stuff, they actually sell the little blackjack card counter things.
They do.
Or it's like is it blackjack? It's like if the dealer has this thing like one card.
This is the chance of you.
Yeah, but the thing is they do that to think that you're gonna like somehow get some like esoteric knowledge and you're gonna go in there and take the house. And people go up there and just be like, but I have this thing, and they put more money down. Oh,
yes.
But I got this thing, I'm gonna put more money down.
That's the wrong. What you've nailed is the gambler's ruin. You're looking at the wrong way. You're looking at what people will do is they ignore the fact that there's a negative sign there, and they figure they can beat it. You can't beat the house if you go out of the long. The only way you're gonna beat the house is if you walk up and roll 3 5s on your first roll or within the first say 10 rolls. And leave, exactly. If you keep playing, like you just said, it's like watching that show Deal or No Deal. It's exactly like watching, I can't watch it anymore. Well, A, because I don't have time to watch TV anymore. But number 2, people go, we've come this far, let's keep going. No. What I've discovered, and as a matter of fact, if I can figure this out before Thursday, we can actually play that game in class.
Yeah.
Oh.
Money left.
Hang on. But I figured out a way to maximize your winnings in that game. You know how, Deal or No Deal, remember how that game works? Maybe we'll play in class on Thursday. That might be a good thing to do in class on Thursday. The way it works is, what the hell, let's just play it.
Is that the suitcase one?
Yes, it's a suitcase one. check this out. Let's just play it now. It's okay. This will take us into Thursday, and I'm actually kind of stoked because you guys are actually kind of into this now, which is good. Well, you're into not losing money, which might or might not be the same thing, right?
I haven't learned anything yet.
What's that?
I haven't learned anything yet.
The odds are against me.
That's a very important thing to learn. All right, deal or no deal?
Then your percentage is going to be higher.
Play the game. Yeah. Okay, so here's the. Oh God. Okay, hang on. Okay, here we go. Here's the way the game works. With wonderful sound. So the way this game works on television, your host is Howie Mandel, and there are 26 models holding 26 suitcases. And those suitcases have those dollar amounts in them. A penny, a dollar, 5, 10, 25, 50, 75, so forth and so on. Down to $1 million. One of those suitcases contains $1 million. One contains a penny. The thing to remember here is you will never lose money playing this game if you play this game. At worst, you're going to win a penny. Until the federal government taxes it, then you win half a cent. But whatever. Regardless, you're going to walk away with more than you had when you started because you're going to add to that. So the first thing you do is you pick a briefcase. Let's pick one, friends.
Number 9.
Number 9 it is.
No, don't do it.
What is the chance?
You didn't pick a number. I did.
That's our suitcase. What is the chance that suitcase contains $1 million?
Very unlikely.
Give me a number.
26.
1 in 26. What's the chance that suitcase contains a penny? What's the chance that suitcase contains $713? Careful. 0. There's $713. See if you're paying attention. See if you're paying. What's the chance that suitcase contains less than $1 million?
Like 100%.
25 and 26, right? All the other amounts are less than $1 million.
I thought there was 25 on the board.
Oh, brother, it's all good, it's all good. So there are 26 suitcases. The chance yours has less than $1 million is pretty good. It's a pretty good chance. This is the Monty Hall question with a goofy twist. Now, what we're going to do is we have to pick 6 briefcases that they will open and show you the dollar amounts of. So, you guys throw some numbers out. 6 it is. 6 contains $200,000. We cannot win $200,000 now. 11, 413, 16. Well, we didn't think we had it anyway, right? We need a couple more, right?
22.
22? And do we need one more? Is that correct?
26.
26. Okay. Now, what the banker is doing right now. And now here's the deal. What the banker is doing, and I haven't figured this out yet. It's an abstract algebra question I haven't had time to crunch on. He is offering you about $20,000 to walk away. If he'll buy that suitcase from you for $20,000. My question for you is, what is that suitcase actually worth on average?
I bet you can figure that out.
You can. We all can. We all can figure it out, friends. We all can figure that out because you have the tool now. The average value of that case is each dollar amount left times the corresponding probability of what's left. How many cases are left? 26 minus 7 is 19, I believe.
20 unopened.
Right? There are 20. Oh, 20. It's even easier. There's 20 unopened cases left. So all we've got to do is do 750,000.
Because there's 20 plus 1.
Well, no, that includes it.
Yeah.
Right?
Yeah.
1, 2, 3, 4, 5, 6. Oh no, you're right. It is 19. You're right, Kelly, because we have to account ours in the 20 as part of the average, because that's part of the unknown. We now know what the value of 6 of the suitcases are. We don't know what the other 20's values are, but we know what our suitcase is worth on average. It's that dollar amount times 1/20th, plus that dollar amount times 1/20th, times that dollar amount times 1/20th, times that dollar amount times. It's this problem. And then just add them all together. Now, we don't have to go down very far. You can probably stop before you get to this side over here. Has anybody crunched the value? You can probably even stop once you get to a value. It's way more than this, though, isn't it?
You have to divide it by 20?
By multiplying by the 120 if you've taken care of the division, Holly. That's a great question. That's why we didn't have to divide by 1 over there, because it all sums to 100%.
Okay, got it.
No, it's a great question. All I'm going to do real quick. let me knock out just a couple of them real quick. So we'll do 750,000 plus 500,000 plus, I'm just gonna add a few of the big numbers up. 300,000 plus 100,000. I'll throw the 75,000 on there. Now I'm not gonna add the rest of them in because honestly they're getting so small that they're not gonna contribute all that much. It's kind of like the 6.7 cents over there. So we'll divide that by 20. Our average value is about $86,250. Now I didn't add in all the other amounts. It's actually a little bit more than that. So let's say it's $100,000. Say it's $100,000. My prediction, and I haven't tested this yet, is if the banker offers you anywhere near a quarter of what the case is worth, you should stop playing most of the time. And that's about a quarter of what the case is worth. I agree with Gabe when he said stop playing.
Yeah, take it. Let's try.
But here's what people say. Keep playing. Keep playing. Okay, let's keep playing. No deal. Okay? Which means we keep playing. Remember, he's going to offer us $20,000. Open 5. Give me some numbers. 2. 10. 17.